Here we have a carbon-carbon double bond. One atom away at this end carbon is the allylic position. Notice here the allylic position does have a lone pair of electrons, and so that's one of the patterns. With a lone pair of electrons, we can draw a resonance structure. Now, for the allylic lone pair of electrons, this would be a two-arrow process. And so what I mean by that is we can draw a resonance structure where these electrons go in between two carbon atoms. But we don't want to break the octet for that middle carbon. Let's not forget that middle carbon, we see double bond and a single bond, that's 3 bonds. That carbon has a formal charge of 0, so it does have one hydrogen that's not drawn. When I move these electrons over and form a new bond, I don't want to break the octet for this carbon. So when you have allylic lone pairs that move around, we'll have to add a second arrow. This is one of these two-arrow processes. And be very specific. Draw that arrow pointing to that last carbon. And so we'll draw the double-headed arrow. Here's a double bond here on this carbon. And at the end carbon, we have to draw those pi electrons that are now sitting on the end carbon. Now for this example, I want to show you the Lewis structures. At the end, recall we've got the carbon with the lone pair of electrons, so that's a negative formal charge. And so by moving those electrons, the carbon at the end over here has the single bond, still has those 2 hydrogen atoms. Remember, one rule, never break sigma bonds. Now we have a double bond here and still 2 hydrogens. So that last carbon now becomes a formal charge of 0.